everyone, welcome back to Teachita differential equations. Today we're going to continue on homogeneous differential equations and specific cases. We are at case 3 where the function, the differential equation, was in the form of dy over dx equal to f of ax plus by plus c over ex plus dy plus n. Basically, it's a fraction. At the top we have line 1 and at the bottom we had line 2. So far we've seen if line 1 and line 2 were both passing through the origin or they were parallel. Today we are looking at case 3 where they're intersecting. They're intersecting at point x0 and y0 and not passing through origin, or basically x0 and y0 is not 0 and 0. So in such case, what we're gonna do, we're gonna move the origin to x0 and y0, and then it becomes like case 1. So basically they're both passing. In such case they would be both passing through the origin and they're intersecting at origin as well. So how do we do that? With a change of variable. So basically we're gonna say x would be equal to x capital plus x0 and y would be equal to y capital plus y0, and note that in such case dx is equal to the x capital and dy is equal to the y capital. If you do this change of variable, you would see that your dy over dx, this equation, would become simplified to this form. And then simply, if you can remember, by doing y equal to dx, by doing this change of variable, we can solve this differential equation. Now let's take a look at one example. The example that we have here, y prime is equal to x minus y plus 2 over x plus y minus 1. So the first step is to find the intersecting point. Basically find x0 and y0. When does that happen? When both lines are equal to 0. So basically x minus y plus 2 is equal to 0 and x plus y minus 1 is equal to 0. Simply x is equal to y minus 2 and x equal to 1 minus y. Let's make this x0 y0 to differentiate, and therefore we can say y0 minus 2 is equal to 1 minus y0, which 2y0 is equal to 3, and then y0 would be equal to 3 over 2. Now we're gonna get and plug this back in here. Therefore x0 is equal to 3 over 2 minus 2, which means minus 1 over 2. There we go, we have it now. We know that x0 is minus 1 over 2 and y0 is equal to 3 over 2. So in order to solve it, what are we gonna do? We're gonna say x is equal to, do you recall, x minus 1 over 2 and y is equal to y capital plus 3 over 2. And if we plug this back into our main equation right here, we're gonna have dy capital over dx capital equal to x minus y over x plus y. And we're gonna do a change of variable, y capital is equal to v x capital, and then we know dy capital would be v dx capital plus x dv. That being said, we're gonna go and replace. So now we're gonna say dy over dx would be 1 minus v over 1 plus v, and therefore v plus x dv over dx is equal to 1 minus v over 1 plus v. Therefore x dv over dx is equal to 1 minus v over 1 plus v minus v, which is 1 minus v minus v minus v squared. I'm just going to multiply this by that one over 1 plus v, which is 1 minus 2v minus v squared over 1 plus v. Correct? So now we can move this around, and then we're gonna get minus 1 plus v over v squared plus 2v minus 1 equal to dv equal to dx over x. And from here on we can integrate and then solve it. So basically we can integrate, this would be ln, and then so on and so forth. We've seen a lot of example for this specific cases, and that would be it. So far we covered all the cases. So we had intersecting at origin. We had case 2 where the lines were parallel, and case 3 intersecting at x0 and y0. And that would be it for this case. In the next lecture we're gonna open up a new chapter and we'll continue with this course. Thank you very much, and see you guys next time.